This lecture is on some trigonometric identities, specifically the sum and difference formulas. And we use the sine and cosine ones a lot, tangent not as much. So the sine of a sum is not the sum of the sines. That is, sine u plus v is not sine u plus sine v. It's more complicated than that, and there are some proofs, as you can see in the textbook, involving things like the law of cosines. But these are our sum and difference formulas right here. Notice that for sine of the first, cosine of the second, positive goes to positive, cosine of the first, sine of the second, negative goes to negative. For cosine, it's both cosines, then both sines, and the signs are opposite, plus, minus, and minus goes to plus. For tangent, the formulas are pretty similar for sum and difference, but you see the signs are switched as well. Plus on top, minus on the bottom, minus is minus on top, plus on the bottom. So we can write these a little bit more compactly over here, using the alpha and beta as our angles. Here I've done for sine and cosine, I've written more compactly. Plus goes to plus, minus to minus, plus goes to minus, and minus to plus. And so using those formulas, several different things we can do, starting off with finding the exact value of sine, cosine, and tangent of 7 pi over 12. 7 pi over 12 is not a reference angle. However, we can express it one of several ways. One of them is pi over 3 plus pi over 4. And since these are reference angles, we can use our sine addition formula. Sine pi over 3 plus pi over 4 is equal to sine of the first, cosine of the second, plus goes to plus, cosine of the first, sine of the second. Then you evaluate these using your knowledge of the unit circle and put it all together, and this is the exact value for sine of 7 pi over 12. Cosine 7 pi over 12, same idea. Express it as cosine pi over 3 plus pi over 4. Cosine of the first, cosine of the second, the sign changes. Plus goes to minus. Sine of the first, sine of the second. Then use your values you know from the unit circle. And rad 2 minus rad 6 over 4 is the exact value of cosine 7 pi over 12. For tangent, you can always do sine over cosine. But using the formula, tan of the first, sine stays the same, plus tan of the second, 1 minus, because the sign changes down here, tan first times tan second. And then we figure out what these are using our unit circle values and rationalize the denominator to get a little past here, and we can get all the way down to here. Another way to do it would have been to divide sine pi over 12 by cosine pi over, sine 7 pi over 12 by cosine 7 pi over 12, and then fix it up. You'd end up getting this. Okay, back over to this one. This is the same idea but in degrees. So 195 is not a reference angle, but we can think of it as 225 minus 30. So we use the sine difference formula. Sine of the first, cosine of the second, sine stays the same, minus to minus. Cosine of the first, sine of the second. Know your unit circle values and plug them all in, and you get to here. Cosine 195 is cosine 225 minus 30. Cosine of the first, cosine of the second. The sign changes, so now it's plus. Sine of the first, sine of the second. Know your unit circle values, plug it all in, and get to here. And then tan 195 for this one, let's just do sine over cosine. And so we use the values we got from before. I flipped the second one and multiplied, and I get it to here. And I didn't rationalize the denominator that time. I just left it as is. Okay, the idea here is not expanding as we did a moment ago, but contracting. So when you look at this, you recognize it as a tan difference formula. So it's a matter of finding the right template. So the template is tan difference, so this contracts to tan 140 minus 60, and we can just leave it as tan 80. All right, different type of problem. We know that the sine of u is 5 over 13, we're in quadrant 1. Cosine of v is negative 3/5, we're in quadrant 2, and we want to find sine of u minus v. So the first thing I'm going to do is expand this using a sine difference formula, and I get to here. Well, I know sine u, and I know cosine v, but I don't know cosine u, and I don't know sine v. So I need to figure these out, and the way I do it is by drawing what's going on. So I go ahead and I draw a unit circle, quadrant 1 for sine is 5/13. So opposite is 5, hypotenuse 13, use the Pythagorean theorem to get 12, and so I know the cosine of that angle is adjacent over hypotenuse 12/13. Same thing for this one. I draw it in quadrant 2 though, Q2, so negative 3 is adjacent, 5 is the hypotenuse. Always make the hypotenuse positive. I made this negative 3 because I'm going left. Pythagorean theorem gives me 4, so sine's opposite over hypotenuse, 4 over 5, so 4/5. Now I can take these 4 values and plug them in here. So that's what we have our expression. We plug in all of these, and then we simply put it all together into negative 63 over 65. Okay, this is now simplifying a trig expression, so before we can simplify, we actually have to expand it. So we expand it using the cosine addition. Cosine first, cosine second, sine changes, sine first, sine second, plus, do the same thing over here. Cosine first, cosine second, sine changes, so it's a plus, sine first, sine second, and obviously these guys are going to cancel, so you'll get cosine x, cosine y, plus cosine x, cosine y, or 2 of them. All right, for this type of problem, we're told in the text that we can simplify this expression down to a single sign by using this particular formula where C is the inverse tan of B over A. The reason to do this sort of thing would be if you have a combination of two trig functions, a sine and a cosine with the same period here, what you can do is write it as just one. It makes it easier to analyze the function overall as far as its period, phase shift, amplitude, that sort of thing. So we identify from here what our little a, little b, and big B are. So A is 12, B is 5, big B is 3. So therefore C is inverse tan of 5/12, and then we go ahead and just plug it into the formula up here. Okay, this is, again, simplifying an expression. So we have sine of an addition. So sine of the first times cosine of the second plus, sine stays the same, cosine of the first, sine of the second. All right. So let's see. So cosine of arc cosine is x. Sine of arc sine is x. So x times x is x squared. So all of this simplifies to x squared, and then I rewrote these pieces. So I've got to find cosine of arc sine of x and sine of arc cosine of x. And to do that, to get these expressions, the way to do it is to use right triangles. So sine is opposite over hypotenuse, so x is like x over 1. Pythagorean theorem to get to here. And then cosine of this angle is adjacent over hypotenuse, so rad 1 minus x squared over 1, rad 1 minus x squared. I do the same thing to find sine of arc cosine. Right triangle again, cosine's adjacent over hypotenuse, so x is like x over 1. Pythagorean theorem to get this side, and then the sine of this angle is opposite over hypotenuse, rad 1 minus x squared. When you multiply those together, you get x squared plus 1 minus x squared, which comes out to 1. So it turns out that entire expression just equaled 1, which does end up making sense because the inverse sine and inverse cosine of the same angle is always 90 degrees, and the sine of 90 is 1. If you realize that we're talking about arc sine and arc cosine, so basically since those are cofunctions together, that's going to be 90. And sine of pi over 2, sine of 90 is always 1. Okay, trig equation to solve. So in order to solve this, first we've got to expand it. So we use our sine addition formula. Minus, we use the sine difference formula for that one. And as you can see, these second terms will cancel out. And so we'll have 2 of these. And these cancel out. And sine of pi over 6 is a half. The 2 and the half cancel, so I've got cosine x is equal to 1/2. And that occurs at pi over 3 and 5 pi over 3 if we're looking from just 0 to 2 pi. Another example of this, solving a trigonometric equation using sum and difference formulas. We expand it using the cosine addition formula. And plus expand this one using the cosine difference formula. The second 2 terms cancel, but there's 2 of these first and third ones. So cosine of pi over 4 is rad 2 over 2. Now 2 times rad 2 over 2 is just rad 2. Divide both sides by rad 2, and 1 over rad 2 becomes rad 2 over 2, and that occurs at pi over 4 and 7 pi over 4.